The diagram shows a wedge of mass m in here, and the particle here 4m. So we're asked to show in separate diagrams the forces on the particle and the wedge, and we have got friction for the first time in these questions here. Mu is a third. So let's look at the 4m mass. I'm not going to draw this steeply. So my 4m mass, we have 4mg coming down to the center of the earth. We have my angle here. I'm going to call it A now. And we need to know what's going on in this direction here. In this direction here, we have a reaction in this direction. And we have got mu here in this case, so it's going to be along here. My friction force, or mu r along there. So let's look at the angle. We're told here that the angle is the inverse tan of 2. So here's my angle A. The inverse tan is 2 opposite over adjacent. It's important that 2 is written as 2 over 1, so you can get both sides. Giving me the hypotenuse as root 5. So the cos A is 1 over root 5, and sine A is opposite 2 over root 5. So in this direction down here, we have adjacent to A, so we're 4mg cos A, which is equal to 4mg over root 5. In this direction here, we're going to have 4mg sine A opposite the 8, which is equal to 4mg by 2 over root 5, so 8mg over root 5. I'm just going to look at the question carefully, and my mu is actually between the table and the wedge here, not between the particle and the wedge, so no mu here. My accelerations, well, if we call my acceleration A, which I should put in up here, A going down, and the acceleration of the wedge F going this way, we normally call it the other way around, but it shouldn't matter. F going this way, what can we say is going on perpendicular and parallel to the slopes? So we have A down here. I have my, let me extend it. I want to know what's going on in this direction. I have my angle A, my angle A. I have my acceleration F going in this direction. So that's the hypotenuse, so my right angle needs to be opposing that, which is here. So I'll just change color to make it more visible. On this side, opposite A, we're going to have the sine of A times F, and the sine of A is 2 root 5, so we're going to have 2F over root 5. 2F over root 5 here, and we're going to have the cos version of it, 1F over root 5 on this side, F over root 5. So the acceleration of the particle is A minus F over root 5. So my forces going down in this direction are 8mg over root 5. That's equal to ma. The mass is 4m, and the acceleration we've just gotten to be A minus F over root 5, and perpendicular to the slope in this direction. You can see my acceleration here. So we're going to have 4mg over root 5 minus r is up here, and here's my 4mg over root 5, and that's equal to m, 4m times the acceleration, which we said was down here, this 2f over root 5 times 2f over root 5, which is 4mg over root 5 minus r. is equal to 8 mf over root 5. So I'm just going to put a box around this. Two equations in relation to the particle. So let's see if we can get an equation for or with the wedge. Okay, so now the wedge, what's going on with the wedge? Let's bring it back into focus here. We have, and let's draw it. Here's my wedge, it's just M, so we have mg. Now there is friction between the wedge and the table, so in this direction here we're going to have mu or, but we use or already, so we'll call the reaction between the wedge and the table S. So we'll come back to that in 1 sec. That's just the reaction. We also have, actually let me bring this line up, just make it bigger. So if I put the particle on, there's or in this direction. So I have or down in this direction. And we have the angle A. So I need to know what's going on down here. In this direction and going along in this direction. So I've got my angle A here. So opposite A is going to be or. I'll just write underneath here, or sine A. And along here, or cos A. So what do we get for the sine of A? Just double check. Sine was 2 and cos was 1. Or by 2 over root 5. So 2 or over root 5. And in this direction, just or over root 5. So looking at our mu in this direction, we're going to have mu, we call it S, mu S. So what is S? S is equal to, S is going up. What have we got going down? We've this one coming down and this one coming down. mg plus or over root 5. So mu S is equal to a third of this. mg plus or over root 5. That's mu S. Now we are going to need mu S because we can see mu S is opposing what's going on in this direction, which is the 2 or over root 5. So my equation is going to become 2 or over root 5 minus mu S is equal to ma. So it's just m, and we call the acceleration for this one a. Didn't we call the acceleration a going in that direction? No, we called it f. That's why we should probably keep consistent. Confusing myself. So f, m, f here, not a. So 2 or over root 5, we can sub in mu s. 2 or over root 5, we want or here, minus a third mg, and I'll just multiply it out. It's going to be minus a third or over root 5 minus 1 over minus 1 or, and multiplying this one by this one over 3 root 5 is equal to mf. Okay, so solve this down for or. So let's put the ors together. I have, if I factor out my or, which is what I want on the on its own, I'm gonna need 2 over root 5 for the first one, and then minus 1 over 3 root 5 for the second one. That's going to be equal to mf plus a third mg. I should factor out my m, but I'll do that in a second. So the left hand side, let's, well, your calculator will just do this third for you. Type this into your calculator, but I don't like using calculators. 2 by 3 root 5 is 6 root 5, unless I have to, of course, minus 1 by root 5 over 3 by root 5 is 3 by 5, which is 15. So we're going to get r times 5 root 5 over 15. Yeah, that's going to work out evenly for me. R is equal to root 5 over 3. It's also equal to this right hand side here. And if I factor out my, sorry, r times, not equal, r times root 5 over 3 is equal to m times f plus g over 3. Is that right? mf plus mg over 3. So to get r on its own, I'm going to multiply by 3. Actually, I'll just multiply by 3 first. 3mf, I'll put it back together, and I have to divide by root 5 plus 3g over 3. And then I have to divide by root 5. You know what I mean? 3. So that's going to give me g over root 5. So I can factor the right hand side. I left out the m here today. Should have been in there. M over root 5. Is this going anywhere? That's going to leave me with 3f plus g. Okay, let's see, does this go somewhere else? We have to sub r back in. R back into this equation here. We said r was equal to m over root 5 times 3f plus g. 3f plus g. Will this help? So we're going to get 4mg over root 5 minus this whole thing, m over root 5 by 3f plus g. That's going to be equal to 8mf over root 5. So we can multiply by root 5 and divide by m. And that'll tidy it up for us. So we're left with 4g minus 3f minus g. So this minus 1 here by the 3f and the g equals 8f. So I get 3g is equal to 11f. G is equal to 11. No, what f? We know what g is. F is equal to 3g over 11 meters per second squared. Let's see what we were asked to find. We have f, 3g over 11, the acceleration of the wedge, which was f for us, 3g over 11. Question done. Nice bit of maths involved.